Okay, now we proceed on the example, more example on the binomial distributions. So before that, I would like to repeat what is the binomial distribution. So when we talk about the binomial distribution, we have these notations. So this is the formula. Okay, when we want to calculate the probability by using the binomial distribution, so this is the formula of the binomial distributions. Okay, so this P is the probability of success, Q is the probability of failure, in which your Q is 1 minus P. Okay, the most important thing is how you want to determine the question is the binomial distribution. So it is a binomial distribution when you have the n number of trial and we have probability of success. So how to know that it is a probability of success? Okay, usually we let our P is equal to the probability of success. Okay, it depends from the question. So if the question asks you to find the probability of getting hit. For example, when you're tossing a coin, okay, then the question asks you what is the probability of getting hit. Okay, so your probability of success is equal to getting hit. Okay, so usually you're getting hit with 0.5 lah. Then we have your Q. Okay, if your P success getting hit, that means your Q is getting tail. Is equal to 1 minus P. That means 1 minus 0.5. Then you get 0.5. Okay, so this is the P and Q, probability of success, probability of failure, and N is the number of trial. Okay, you get it from the question. And your S is number of success in a trial. So usually your S is from the question. What is the probability of getting, let's say, 2 hit, for example? Okay, so your S equal to 2. Okay, now we look at the example. Okay, now, so this is the example. Okay, we have the example 7. So this example 7 is from your textbook. Okay, from the notes that I already give. Okay, so example 7. Assume that when a certain hunter shoots at a bird from 5, the probability of eating it is 0.6. Find the probability that the hunter will hit at least 4 birds. Okay, now we have the word from the question, we have hit, will hit. So this is your P, probability of success. So that means the certain hunter shoot at a bird from 5, the probability of hitting. Okay, so we have your probability of success is 0.6, and from the questions, okay, also ask about the probability hit. So that means your probability of success is 0.6. So you can use your P is equal to 0.6. So it goes same for the question number B, will hit at least 1 bird. So again, we have the probability of success is same. Okay, it is given probability of hitting 0.6. The question asks the probability of hit. Okay, so we have the same probability of success. Okay, now okay, so we have certain hunter shoot at a bird from 5. So we have the word from 5. So this is the number of trial. That means your N is equal to 5. Okay, so from here, from the question, we already have the information of the number of trial and the probability of success, so that we can use the binomial because we have the value of N is 5 and we have the probability of success which is 0.6. Okay, so we can use binomial distribution for this question. Okay, now, so the question will hit at least 4. Okay, so it will at least 4. Okay, now, so like I said before, we can get the value of x, okay, from the question, what the question asks for. So the question asks to find the probability that the hunter will hit at least 4. Okay, that's mean x greater or equal to 4. So you are going to look for the probability when your x greater equal to 4. Okay, so when your x greater and equal to 4, that's mean x equal to 4. And also, it can be when your x equal to 5. Okay, we have number of trial up to 5. So we stop at x equal to 5. So when your x equal to 4, so we have your n is 5. Combination of your x is 4. Our p is 0.6. Okay, then our x is 4. Our q is 1. Okay, q is 1 minus p. That means 1 minus 0.6. We have 0.4. Okay, so it's 0.4. Then n minus x. Our n is 5 minus our x is 4. So we have 5 minus 4, which equal to 1. Okay, then when your x equal to 5, we have n combination of x. Our x is 5, 0.6. Okay, then px, our x is 5, and we have 0.4 is our q, and minus s is 5 minus 5. Okay, then we get the answer 0.2592 plus 0.077. It then we get is equal to 0.3370. Okay. Okay, now we proceed to question number B. Will hit at least one bird. That means our x greater or equal to 1. Okay, at least one bird. So we are going to look for the probability when your x greater or equal to 1. Okay, so when greater equal to 1, it can be when your x equal to 1. Okay, or when your x equal to 2, or when your x equal to 3, or when your x equal to 4, or when your x equal to 5. So we have number of trial up to 5, so we stop at when your x equal to 5. Okay, now, but you know that we have learn the theory, okay, in which for each event, okay, your probability of A is equal to 1 minus the probability of implement of A. Okay, so we can use this theory, okay, in which from this x equal to 1, x 2, 3, 4 and 5, okay, the probability that is excluded from this event is probability when your x equal to 0. Betul tak? 0 tak masuk. So we have x1, 2, 3, 4, 5. Tapi when your x equal to 0, tak masuk. So it's equal to 1 minus probability when your x equal to 0. So 1 minus probability when your x equal to 0. So you have to calculate what is the probability when your x equal to 0. It's the n. Okay, you use the formula. Our n is our 5. C, our x is equal to 0. Okay, then we have the p, 0.6. Okay, x is still 0. And we have q, 0.4. Then we have n minus x, 5 minus 0. Okay, so after we solve this, okay, then we get the answer is equal to y minus 0.0102 is equal to 0.9898.